Here I have a Hardy Weinberg equation completed for you, and what you will do is identify all of the values in regard to the following questions. What I highly suggest that you do right now is press pause and answer all of the questions. Then see as I go through them if you're correct. Also, you can make your own Hardy Weinberg square and then use the following questions and go over them with a friend. That's a great way to review. So right now, again, that would be the time to pause and answer all of these questions so that you can ensure you are ready to understand everything about Hardy Weinberg. All right, so let's go through the following questions. One of the things that I would do is I would label my Hardy Weinberg Punnett square here with all of the values. So this would be P, Q, P, Q, P squared, P, Q, P, Q, and Q squared. So that makes for a nice little key for you to work off of. Now, let's go through these questions. What percent of the population is homozygous dominant? Okay, so now we're talking about traits. Remember that traits are found on the inside and genes or alleles are on the side and the top or on the outside. The homozygous dominant trait, what that means, homozygous means two of the same, and the alleles would be dominant. So homozygous dominant is expressed as P squared. That shows us here 15.4%. What is P? P is the percent of the dominant allele in this population. P shows us that it is 39.2%. What percent of the alleles or genes are dominant? Wait a minute, that sounds familiar. Oh wait, that's the same as this last question. It's just worded in a different way to give the same number. The dominant alleles in the population are P. Again, 39.2%. What percent of the population shows the recessive trait? Okay, wait, traits again are on the inside. 0.37 or Q squared shows the recessive trait, which would be 37%. What is the frequency of P squared? Frequency is also another word for percentage. So here we've got 0.154 or 15.4%. What percent of the population shows the dominant trait? Ooh, this is probably your hardest one to figure out. Remember that the dominant trait is going to be showed by, for example, if we're talking about complete dominance, a capital R, and a capital R, small r. Those that show the dominant trait are both homozygous dominant and heterozygous. That also means we're talking about P squared plus R2 PQs. So in here, you're going to add P squared 0.154 plus 0.238, that's our first PQ, and also 0.238, our second PQ. When I add all three of these boxes that appear dominant, what I am going to get is 63%. What is Q? Q. Okay, here's Q, 0.608, Q, 0.608. So Q is 60.8%. What percent of the population is homozygous? Remember, homozygous means same. And recessive is the lower case. Two of the same recessive would be little r. And that would be our Q squared, or 37%. What is the percent for 2PQ? I'm going to take one PQ, 0.238, and the other PQ, 0.238. I'm going to add them together. And what I'm going to get is 47.6%. What percent of the population shows the recessive trait? The recessive trait is shown by Q squared or homozygous recessive. So Q squared is 37%. What is the frequency of Q squared? Oh, wait, we just answered that, right? Same thing here. Again, that Q squared, homozygous recessive, or the percent that show the recessive trait, is this square right here, or 37%. What percent of the population is heterozygous? That is going to be adding up our two PQs. When we add up 0.238 and 0.238, what we get is we get 47.6%. So just remember that when we are talking about these different values, that P is the frequency of the dominant allele in the population, Q is the frequency of the recessive allele in the population, P squared is the frequency or percent of individuals in the population that show the homozygous dominant trait, or capital R, capital R. PQ and PQ are both heterozygous, capital R, small r. We add both of these up to get to PQ, or the percent of individuals in the population who show the heterozygous trait. Remember that PQ, P squared, and our other PQ, they all look dominant according to the principles of the complete dominance type of inheritance. 37% down here is Q squared. Q squared represents the percent of individuals in the population who show the homozygous recessive trait, or who are showing the recessive phenotype. The dominant phenotype are shown by P squared and our 2PQ. Show the dominant trait, or the dominant phenotype shows the recessive trait, or the recessive phenotype. All right, if you've got all of these questions down and understand them, you should be ready to answer questions about a Hardy Weinberg equation.